Hello, today we are going to talk about scientific notation. A quick way to write really big numbers or really small numbers. So let's get started. This video will be a whisk, watch, summarize, and question. So you're going to watch this video, you're going to summarize. I gave you some ideas that I want you to talk about in your summary. I need you to talk about how to take a large number and put it into scientific notation. I need you to talk about taking a small number and putting it into scientific notation. And I want you to summarize the process of taking a number in scientific notation and making it just a regular number. All right? And then you will ask your question at the end of your summary. Okay? I'm going to go over a few examples throughout this PowerPoint, and I'd like you to just copy down those examples. Okay? So let's get started. So mathematicians like shortcuts. They decided that by using powers of 10, they can create shorter versions of really long numbers. Okay? So, rules. This is a very important rule. All right? That for a number to be in scientific notation, the leading number needs to be between 1 and 10. All right? In fact, it cannot be a two-digit number. It has to be less than 10 and bigger than 1. All right? 1 or bigger. All right, and then it's multiplied by a power of 10. So this is a power of 10. This is the number 23. So why is 23 not in proper scientific notation? Because 23 should actually be 2.3. We need to move that decimal back one more place value and make this 10 to the 6th in order for this problem to be in scientific notation. Again, the leading number is not between 1 and 10. So we can take this large number here, 137 million, can be written as this, 1.37 times 10 to the 8th. Now before we get into, okay, I move the decimal left or right, I think that's the way I learned it. You just kind of memorize which direction and whether I'm going to use a positive or negative exponent. Here's what I want you to think of, okay? This number right here, 10 to the 8th, is 1 with 8 zeros after it. It is a very large number, okay? And I'm taking a small number, 1.37, and multiplying by a large number. That result is going to give me a large number. Okay? I think that'll make more sense as I get into the negative exponent values as well. All right? So I took a very large number and made the first part small. Therefore, I have to multiply by a large number to keep these two quantities equal. Okay? How do they get 8? They move the decimal from here all the way back, 1, 2, 3, 4, 5, 6, 7, 8 to make this 1.37. They couldn't move it farther because 0.137 is less than 1, and they couldn't have kept it at here, 13.7, because 13 is bigger than 10, and that violates our rule from the last, our rule for scientific notation. Okay? So, let's take a look. We're going to use scientific notation to rewrite the following numbers. So we really want to take this decimal place and move it backwards until the number we start with is between 1 and 10. All right, so in this case, move it back 1, 2, 3, 4, 5 places. So that's going to be 3.47 times 10 to the 5th power. All right, I have a small number, a number 3.47, so not much bigger than 3. And if I multiply that number by 10 to the 5th, so 1 with 5 zeros after it, that will give me the 347,000. Okay? Same with 902 million. 1, 2, 3, 4, 5, 6, 7, 8 places. 9.02 times 10 to the 8th. 61,400. Take our decimal, move it back. 1, 2, 3, 4. 6.14 times 10 to the 4th power. Again, I'm taking a large number and I'm writing it in scientific notation, remembering that my power of 10 needs to be a large number to make this small number equal to this large number. Okay? All right. So now we're going to go backwards. So again, I have this number 1.23 times 10 to the 5th power. I have a small number, I'm multiplying it by 10 to the 5th, which is a big number, so this number is going to get larger. All right, and so that means I'm going to move the decimal to the right 5 places. Okay, And so what that looks like, it was 1.23 if I pretend my decimal's still there and I count 1, 2, 3, 4, 5. All right, so that is where we're getting the extra 3 zeros. I moved it over 2, and then I got 3 more spaces, so I'm going to add 3 more zeros. All right, let's take a look at this one. 6.806 times 10 to the 6. I have to move this forward 6 places. A small number I have to make larger. So 6.8 I got to make bigger. So by 6 decimal places. 1, 2, 3, and then 4, 5, 6. I'm going to add 3 extra zeros here, and I get that. I'm going to add a pen tool here. So one thing you'll see a lot of teachers do, I think this is a good idea, is they'll draw the movement, and they call these like egg holders. So every empty egg holder, there's 1 empty, 2 empty, 3 empty, I'm going to fill in with a 0. Sorry, that's not quite lined up. Oh, that one's even worse. And there's the last one. And that would tell me how many zeros I need to fill in. All right. All right, so we have a few more. I'm going to convert this one to scientific notation. So my decimal's here. I'm going to go back 1, 2, 3, 4 times 10 to the third. This one I'm going to put into as a regular number. So 1, 2, and I got to add one more empty spot for 10 to the third. 2,480. And then the last, or 2 more. So the last one that we have to convert to a regular number, I'm going to move it forward 1, 2, 3, 4, 5, 6, 3 empty placeholders. So 3 extra zeros. And then this one we're going to go back 1, 2, 3, 4, 5, 6, 7, 8. So there my decimal is going to go between the 3 and the 0 there. 3.06 times 10 to the 8th power. All right. I hope that helped with converting back and forth with larger numbers, again with positive exponents. Okay. I'm going to skip through these actually. Okay, so why does a negative exponent give us a small number? Okay, and here's a little pattern here. So we have 10,000, which is 1 with 1, 2, 3, 4 zeros, is 10 to the 4th, 10 times 10 times 10 times 10. And then 1,000 is 10 to the 3rd, 100 is 10 to the 2nd power, 10 is just 10 to the 1st power, and 1 is 10 to the 0 power. Okay, and if I were to keep going, I would get into these negative exponents. All right, so I get 1/10, 1 over 10 squared, 1 over 10 cubed, 1 over 10 to the 4th. Noticing these fractions over here. So 100 is still 10 squared, 1,000 is still 10 cubed, 10,000 is still 10 to the 4th. All right, but we don't write them like this. Well, we can, but in scientific notation, we actually write it a different way with negative exponents. Okay, 1 over 10 is 10 to the negative 1st. So the one thing I know we always struggle with in algebra is simply that a negative exponent makes a negative number. It does not. It makes a number smaller. Okay, so 1 over 10 to the 2nd power is 10 to the negative 2nd, and you can see we continue the pattern. Okay, now we're taking a very small number and we're going to make it larger. Okay, so it's going to look larger at first. We're going to have 8.82 times 10 to some power. Now remember that we're taking this very small number and making it larger, that we should be using the negative exponents, because when I get my 8.82 times 10 to the negative 4th, I need to make this number 8.82 smaller to match that. So that's why we're using the negative exponents here. All right, so just look at your end result. This is a small number. This is bigger. I have to make this smaller by multiplication, so I'm going to use negative exponents. Same thing here. 1, 2, 3, 4, 5, 6, 7 spaces. So 5.9 times 10 to the negative 7th. 1, 2, 3, 4, 5. 4 times 10 to the negative 5th. All right. So again, we just we go through pen tool. And we're going to go 1, 2, 3, 4, 5. And that tells me what my exponent is. All right, so we'll do these examples here. Again, moving forward, 1, 2, 3, 4. 4 times 10 to the negative fourth. All right. Now here, this is going backwards. This is another summary you want to talk about. I got to look at my 10 to the negative 6. That makes numbers smaller. So I have to make 1.248 a smaller number. So instead of memorizing that I have a negative exponent, I move my decimal back, just realize that I'm taking a number and I'm making it smaller. It should be very obvious to you which direction you have to move that in. Okay. And I'm going to get, my decimal was here, I should be back 6 spaces. 1, 2, 3, 4, 5, 6. Perfect. Same thing here. I'll move this one back 5 spaces, taking a number like 6 and I'm making it smaller, so I got to move that backwards. And that should give me, let's give it a quick check. 1, 2, 3, 4, 5. Perfect. 3.06, same thing. Oh, nope. Now we're going back to converting again into scientific notation. So I got to get that number between 1 and 10. So I got to move the decimal. 1, 2, 3, 4, 5, 6 places. 3.06 times 10 to the negative 6. And 1, 2, 3, 4. 4 places. 8.92 times 10 to the negative fourth. All right, here's another example. A ribosome, another part of a cell, is about, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. I'm not even sure what we would call that. Of a meter in diameter. Write the length in scientific notation. So we're going to take this very small number and we're going to make it larger by making this 3.0 or 3 times 10 to some power. And because this is a small number we're making look larger, we're going to use a negative exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 10 to the negative 9th. Good work. Oh, let me go back to this really quick. So, that wraps up our video on scientific notation. To kind of recap, I definitely want to talk really quick about, again, a problem like this, taking a small number like 1.23 and making it larger with a number like 10 to the 5th with a positive exponent. And then going through and looking at our negative examples, like here, taking a very small number, making it look larger, and using negative exponents. Okay? I hope this helps, and I will see you guys next time.